Hello, and welcome to A Gross of Physics. Today's day 16, and what I'd like to look at today is reaction time. I'm going to start with the little magic trick, although it may be more of a carnival trick, and don't we all love going to carnivals with the cotton candy and the fried dough? But I digress. In this case, you can play a trick on your friends and ask them to try to catch a dollar bill. And what I have here is a regular dollar bill. It's got George Washington right on the front. And all you have to do is ask your friend to catch the bill. You're going to drop it, and they're going to catch it. And the only caveat is they have to keep their fingers near the head of George. So you're going to let go of the bill, and they're going to catch it. And it's going to be as simple as that. If they catch the bill, you can tell them they can keep the bill. If they miss it, though, they owe you one. So, in this case, we can use physics and reaction time in order to better our chances of winning this little bet. The dollar bill has a certain length, and it's standardized. In fact, it's about 16 centimeters. If we were to divide that in half, it's 8 centimeters. And what we're going to do is only allow the person to catch the bill between the head and the bottom of the bill. When it passes by their fingers and they close their fingers together, their chances of getting that bill are gone. So how is physics related to this little trick? Well, the average reaction time is about 0.3 seconds. And what we'll see when we do the math is that if we use 8 centimeters as our displacement, negative because it's down, convert it to meters, so 0.08, and drop the dollar bill, so VI is 0, we can calculate the amount of time that someone has in order to catch the bill. If we did the 16 centimeters, the full length of the bill, they'd have a better chance. And that's why it's half the bill in order to catch it. So what we do is use VI as 0, A is negative 9.8 meters per second squared, and D is negative 0.08 meters. If we calculate T, we'll find that you have 0.128 seconds in order to catch the bill. Now, as I said before, the average reaction time is 0.3 seconds. So the majority of people will actually miss the bill, and it will fall and flutter to the ground. If you hold it sideways, wind resistance will take over, and the person will have an easy way to catch it. Plus, they'll smush the bill. So you need to make sure that it's going to fall as straight as possible. So when you drop it, they'll be able to miss it. Well, in this case, they'll miss it. Now, why am I able to catch it each time? Well, I know when I'm going to drop it. And I'm able to show that because my brain is already sending the signal to squeeze my fingers, my reaction time to catch this bill is not actually 0.3. It's much less. So I can make it look easy when I'm dropping it myself. For anyone else, they're going to have to react to me dropping it. Now, over time, some people will catch the bill, but the majority of them will miss because the average reaction time, as I said, is 0.3 seconds. The only way to really catch the bill is to anticipate when it's going to be dropped and actually close your fingers a little before the person drops it. Now, you may be asking, well, what is my actual reaction time? Well, you can test this at home. All you have to do is take a meter stick or a ruler and have someone drop the ruler and you catch it just like we did with the dollar bill. What you can do is take a centimeter ruler, maybe a 12-inch ruler that has the metric system on it, and have your fingers start at the bottom of the ruler at the 0 mark. As long as the person dropping is someone you trust and they're not going to throw the ruler downward, then you can figure out your reaction time. All you need to do is have them drop it a number of times, 3, 4, maybe 5. And you don't need to time anything. All you need to do is read the value where your fingers clamp onto the ruler. If you average those 5 trials, that's going to be your displacement. Make sure it's in the negative direction. As long as you trust that they dropped the meter stick each time, that's going to be a VI of 0. The acceleration is negative 9.8 meters per second squared. And you can calculate for T. T becomes your reaction time. See if you can have a reaction time less than 0.3 seconds. Now, as I said, the average reaction time is 0.3. As you get older, your reaction time slows. If you're under the influence of medication or drugs, your reaction time would decrease as well. And that's why it's important that people realize that driving is very dangerous when they're on medication or they're under the influence of drugs that will cause them to have slowed reaction time. That is why drinking and driving is so dangerous. So, at this point, you could figure out your reaction time. Take a ruler, have someone drop it for you about 3, 4, or 5 times, record the distances it falls each time, and calculate for time. I gave you a new trick, a new magic trick, and although I'm not a magician, I'm a physics teacher, I'm pretty sure I'm not going to be expelled from the Magician's Guild. Thank you.